Hello, this is the genuinely approachable Sudoku for the 20th of February 2024. It is greater than by Clover, so let's look at the rules of this puzzle. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Inequality signs in the grid indicate which of the two adjacent digits is greater. Oh, that's it. Okay. So for example, those two digits, the open end of the symbol points to the greater digit. So here you have like a V shape that kind of has an open end on one side that points to the greater digit, for example. And I guess it works as a traditional inequality sign, which is to say that the one it's pointing at is actually the smaller digit. So something like a 5 would work here, but this being an 8 would not work because 7 is not greater than 8. So with that, let us begin solving. I guess we can start with this 8 over here, which must have only one thing that's greater than it, which is a 9. This 7 now has two things greater than it, 8 or 9, but there can't be a 9 here, so this must be 8. The same logic applies to this 6, pushing a 7 into that cell. Now 9 can't be any of those cells, and this cell therefore can't be 9, 8, 7 or 6, but it must be greater than 4, therefore must be 5. That digit must therefore be a 4. Now we have those digits being 1, 2, 3, and 9. Whoa. 1, 2, 3, and 9. 3 can't be in those cells, but also that digit is greater than at least two other digits, and therefore can't be 1 or 2, because 2 is, 1 doesn't have anything less than it, and 2 doesn't have two things less than it. So this must just be 9. Yeah, none of those digits are 9 now. This digit can't be 3, because if it was 3, this would not be bigger than 3. So 3 must go there. Right, so let's do the same with this. I think we can do the same here. This 2 means that has to be 1, this 3 means that has to be 2, this 4 means that has to be 3, by the exact same logic we used up here. These digits must be less than 6 and 7 respectively. This digit in particular can't be 1, 2, 3, and 4, and therefore must be 5. That digit therefore must be 6. The remaining digits are 1, 7, 8, and 9. And this now, 7 can't be in those cells. So this digit has to be smaller than at least two other digits. Well, that's fine, because it now can in fact be 1 or 7, I think. None of those cells can be 1. Alright. Well, there is something different here than up here, I guess. I don't actually quite see the difference. Yeah, it should be identical. I don't know why it's not. Oh, because the arrows are not rotationally symmetrical. Yeah, you see these are pointing in the same direction. The rotationally symmetrical arrows are pointing in the same direction. These are not. They're pointing in rotationally symmetrical directions, which means that they don't actually work the same. Interesting. Okay. I guess we'll do Sudoku now then. Right, because 6 and 7 can't be in those cells and therefore must be here, forming a 6-7 pair. 3 and 4 actually do the same thing, meaning this forms a 3-4 pair. Now 2 therefore must be in one of those cells, which does something. 8 must be in one of those cells, which also does something. I guess 8 here would force us to be 9, but that's possible. Okay, what else do we have? Oh, is it roping? It is. It is roping, because in this box, where do 1, 2, and 3 go? The 1, 2, 3 means those can be 1, 2, or 3. So 1, 2, and 3 go there. None of those digits can be 1, 2, and 3. So 1, 2, 3 go there. This is a 3-4 pair. This is a 3-4 pair. None of those can be 3. 3 goes here. This digit must be greater than that digit, and therefore this digit can't be 1, because there'll be nothing to put there. So this is 2, that's 1. This 2 must therefore see a 1. It's the only thing lower than 2. We can do the same with 7, 8, and 9, I think. 7, 8, and 9 in those cells. Well, 7, 8, and 9 can't be in those cells. So that has to be 7, 8, and 9. 7, 8, and 9 has to be here, therefore. The 6, 7 here and the 6, 7 here remove 7 from those cells, which means 7 goes there. This can't be 9 because there's nothing greater than 9. Therefore must be 8 with only 9 to be greater than it. And the last digits are 4, 5, and 6 in each of these boxes. So 4, 5 here means that is 6. 5, 6 here means that is 4. So you can remove those respectively. Next, what do we have? 6 here means that's not 6, 4 here means that's not 4. I highly suspect this is almost completely X windmill except for the corners here. Those are the only ones that are slightly different. There's also one lone carrot here that doesn't have a counterpart there, but I think that's just for disambiguation purposes. Anyway, 1, 2 pair here means that must be 3. Can I probably do the same here? No, yeah, because again, not the same. I do want to say that because of this 3, this must be a 7, although I can't be entirely sure. Alright. Now what? 3? Yes, 3 in this box. Sorry. Must be here. That digit is therefore less than 3, but can't be 1, so must be 2. The last 3 digits here are 5, 8, 9. That can't be 8. Those digits can't be 9, so 9 must go there. The last 2 digits in this column are 4 and 5, which we can resolve. Which with this 4 here, 5 resolves this 5, 6 pair, which does nothing. Cool. Okay, what do we have here? 6s in this box has to go here. Does that do anything? No, it doesn't. Okay, 6 resolves this 4, 6 pair though. Whoa, wait, why is this a 4, 6 pair? No, that's 4, 5 pair. What did I do there? No idea. Alright, let's look at 1 in this box has to be here. So those digits form a triple, which are 5, 7, 8. 7 can't be there or there. So 7 must be here, which is only greater than 5, it's not greater than 8. Awesome. 5 means this is a 6. Those digits are therefore 2 and 8. There you go, 2, 8. Well, this can't be 8 because the only thing greater than 8 is 9, but there's really 9 in the row. So this just must be 2. That's 8, which resolves this. This makes this a 9. This therefore can't be 8 or 9, is therefore a 1. That's 7, that's 8. So this means that isn't actually a 7. This is an 8 or 9, so that's 7. This over here means that those digits are 1 and 6. 8 and 9 means those digits, sorry, are 2, 8, 9. We have that. In fact, 9 can't be there. And those digits do form a triple as well. 7, 8, 9 triple. This can't be 9 again. I don't know what else we have here though. Maybe that inequality does something. 8 must have a 9 behind, although I think that's fine. What else do we have? Those digits? Those digits are 1, 2, and 3. This can't be 1, this can't be 2. Those digits are also a triple. They are 4, 5, and 9. 9 can't be here, so 9 goes there. This 4, 5 means that has to be greater than it. But 6, 7, 8, 9, 8 and 9 are all used. So the only thing that's greater than one of those digits is 5, which is greater than 4. Which resolves everything, I think. 1, 2, 3 here, 4 there, resolves this 4, 5 pair. Which actually this 3, 4 pair already resolved a long time ago. What do we have now? We have this entire block here. That digit is just a 1. 5 resolves this 4, 5 pair. Yeah, what do we have here? I'm pretty sure there's something. 5 resolves this 5, 8 pair. And this 8 means this must be a 9. It's the only thing greater than 8, which resolves just about everything. 7 here means this is 6, 7. 6 here means this is 1, 6. 1 here means this is 2, 1. And finally 2 here means this must be 8. The last digit here is a 2, finishing the puzzle in 8 minutes and 1 seconds. Awesome. Well, I hope you enjoyed that video. I'll see you next time. Bye bye.